Hello everyone, thank you for joining us today. This presentation will review Glass Expansion's line of high-quality ICP-MS cones and provide guidance on choosing the best cones to suit your application. In addition to selection, we'll detail proper cleaning and maintenance procedures. First, we would like to quickly address product design, manufacturing, and the importance of quality. Glass Expansion is an international supplier with over 30 years of experience in designing and manufacturing ICP-OES and ICP-MS sample introduction components, and has earned a worldwide reputation for quality and reliability. Our world-class manufacturing and R&D teams have produced many product designs which are considered ICP industry standards. We manufacture ICP-MS cones to the same exacting standards as all of our products, and they are guaranteed to perform to your satisfaction. Glass Expansion is proud to be the first and only manufacturer with the required technology and equipment to produce the full range of ICP-MS cones entirely in-house. Our capabilities for this include CNC machining, precision grinding, electron beam welding, and electrolysis nickel plating. This results in being able to maintain the highest level of precision, quality, and reliability standards, as we are able to control every step of the production, including raw material selection. All Glass Expansion cone designs are tested and evaluated with a variety of applications, either within our own R&D lab or at customer sites across the globe, before they are made available for sale. Our cones are guaranteed to either meet or exceed OEM specifications. And with our warranty policy, you have our guarantee. Glass Expansion Inc. was also awarded a GSA contract number in 2019 to help expand our support to the U.S. government laboratories. We supply cones for all the popular ICP-MS instruments, including models from Agilent, New Instruments, PerkinElmer, Shimadzu, and Thermo Fisher Scientific. We also recently added the Fluidigm Helios time-of-flight ICP-MS to our ICP-MS cone catalog. These options, along with the corresponding cone raw material, are listed on this slide here. To view our complete selection of ICP-MS cones, please visit geicp.com/intro/cones. Just a quick note on material selection. The material the cones are made from, for example, solid nickel, a nickel insert with a nickel-plated copper base, a platinum insert with a copper base, and so on, is a matter of both sample matrix as well as how the specific instrument is designed to be operated, meaning the plasma conditions. And Glass Expansion's cone offerings are specifically designed to match the recommendations of each OEM. The three most common materials are copper, nickel, platinum, although aluminum is available for some instrument models, which is preferred for the low background when nickel is an analyte of interest. This will all be covered in more detail within a few minutes. Now let's just have a very brief review of the purpose of cones. The cones are the first component of what is called the interface region, the role of which is to transport the ions from the plasma, which is at atmospheric pressure, to the mass spectrometer region, which is under vacuum. Typically, the interface consists of two cones, the sampler and the skimmer, but some ICP-MS instruments do have a third cone called the hyperskimmer. After the ions are generated in the plasma, they are directed to and pass through the first cone, which is the sampler cone, and is typically the larger of the two, with an orifice ID generally between 0.8 to 1.2 millimeter. They are then directed through the skimmer cone, which is typically the smaller of the two, with an orifice ID generally between 0.4 and 0.8 millimeter. Once the ions pass through the skimmer cone, you can think of them as now being inside the spectrometer. From here, they will be guided through the optics to a collision or reaction cell, if equipped, and then down on all the way through to the detector. So why does cone material matter? The plasma discharge interface region is an extremely aggressive environment. The coupling of high temperature ionization source, the plasma, to the metallic interface of the spectrometer imposes demands on this region of the instrument that are unique to ICP-MS. When this is combined with a matrix, solvent, and analyte ions, along with particulates and neutral species being directed at a high velocity towards the interface cones, an extremely harsh environment is the result. Thus, the need to select the correct cones for your application and your matrix. Now let's look at a few of the different materials cones can be manufactured from. Cones made entirely from copper are often the lowest cost option. Since copper is more efficient in terms of heat transfer than nickel or platinum, this means the temperature at the tip of the cone will be lower, or that it runs colder. The consequences of this are that the rate of corrosion will be the highest, along with oxides, salts, and sample deposition at the orifice. This means that there will be a more frequent need for cleaning, perhaps daily. Aside from the extra time required due to increased maintenance, excessive cleaning can actually shorten the lifetime of the cone. Nickel cones are typically the standard option and are suitable for many common applications. Cones made from nickel can include solid nickel, or a nickel insert with a copper base, or a nickel insert with a nickel-plated copper base. These configurations are dependent again on the instrument make and model. For example, there are two nickel-based designs for sampler cones for the Agilent instruments. The standard is a nickel insert with a copper base, but a nickel insert with a nickel-plated copper base is suggested for use with samples that contain higher than a 5% hydrochloric acid matrix. Since nickel is less efficient in terms of heat transfer than copper, this means that the temperature at the tip will be higher, or it runs hotter than copper. This means that the rate of corrosion as compared to copper will be slightly lower, along with oxides, salts, and sample deposition at the orifice. Platinum cones, while obviously more expensive than copper or nickel, are the most durable and longest lasting option. Cones made from platinum are generally a platinum insert with a copper base, but some instruments and applications call for a platinum insert on a nickel base or a nickel-plated copper base. Since platinum is least efficient in terms of heat transfer when compared to copper and nickel, this means the temperature at the tip will be higher, or that it runs hotter than copper and nickel. This results in greater chemical resistance, along with fewer oxides, salts, and sample deposition at the orifice of the cone, as well as fewer polyatomic interferences. Example of applications include high matrix samples, meaning high total dissolved solids and particulates, aggressive or high concentrations of acids, organics, or when the lowest detection limits are needed. For the most aggressive samples, for example, a combination of high total dissolved solids and high acid concentrations, a sampler cone with a larger diameter platinum insert can be used. For some ICP-MS models, a sampler is available in a 10, 15, or even 18 millimeter platinum insert. The larger insert provides a much greater life due to the larger surface area of the platinum insert. Also, unlike nickel cones, platinum can be economically refurbished several times over as long as the orifice and tip of the cone are still in reasonably good condition. This provides an ICP-MS laboratory analyzing high matrix samples with a significant cost savings. Now that we've covered the general guidelines for cone selection based on material, let's take a quick look at an example. The Agilent ICP-MS instruments have a variety of different sampler cone and skimmer cone combinations to help the laboratory achieve optimum performance. Glass expansion sampler cone options for the Agilent 7900 ICP-MS are listed here. With so many options, it can be difficult to choose which option is the best suited for your application. To make the selection process easier, we have listed the general recommendation for a variety of application types. Similarly, we have a list of recommendations for the Agilent 7900 skimmer cone options to complement the sampler cone selection process. It is also recommended by the ICP-MS manufacturer that a platinum skimmer cone be used with a brass skimmer base and a nickel skimmer cone be used with a stainless steel skimmer base on the Agilent ICP-MS instruments. Selecting the proper skimmer base helps to prevent overheating and prolong the life of the platinum skimmer cone. Now we'll move on to cone care and maintenance. First, a note on cone conditioning. To ensure the lowest background levels of copper and nickel, conditioning before use is recommended. A conditioned cone with a uniform coating will also lead to improved long-term stability. Brand new cones and cones that have gone through cleaning should be conditioned prior to use. This is a relatively simple process and can be done during the warm-up phase. All that needs to be done is to aspirate a 50 ppm calcium solution for 10 minutes, followed by a 1% nitric acid solution for 10 minutes. Another recommended cone conditioning procedure is to aspirate your highest matrix sample for at least 30 minutes, followed by 10 minutes of aspirating your blank or rinse solution. This method is helpful if your laboratory is analyzing a common matrix each day. The frequency at which the cones are cleaned depends very much on the application and the workload of the instrument. If the samples are clean and the usage is low, the cones may only need cleaning monthly. But if the instrument is in continuous use, or if the samples contain high levels of dissolved solids or are highly corrosive, the cones may actually need cleaning daily. Please note, you want to avoid unnecessary cleaning, as overcleaning the interface cones can lead to a shortened lifetime. There are both physical signs as well as experimental results that indicate the cone should be cleaned. As the sampler cone is more exposed to the plasma, it will usually need cleaning more frequently than the skimmer cone. If the performance of the instrument does not recover when the cones are cleaned, they may need to be replaced or refurbished. To extend the life of your cones, as well as other sample introduction components, and to decrease the cleaning frequency, always end the run by aspirating an acidified rinse solution followed by DI water for a few minutes. Cones should be cleaned if there are visible deposits near the orifice or if the orifice is blocked or distorted. Deterioration in the performance of the ICP-MS instrument can also indicate that the cones may need cleaning. In particular, you should watch for increased background signal, memory effects, loss of sensitivity, or distorted peak shapes. A change in the instrument vacuum reading can also indicate cone issues. If the orifice gets blocked, the vacuum will increase, pressure decrease. Although there will usually be a deterioration in the performance before this point. If the vacuum decreases, example pressure increases, this could indicate that the orifice is worn and has increased in size. If this happens, the cone needs to be replaced. The method of cleaning will also depend on the application. If the samples are relatively clean, a gentle cleaning process will be sufficient. In some cases, routine cleaning with a cotton swab and DI water is suitable. But if the samples contain high levels of dissolved solids or are highly corrosive, a more aggressive cleaning procedure will be required. And just remember, when cleaning the cones, the goal is not to get them back to like new condition. You only want to remove excess deposition and corrosion and to leave a uniform coating on the surface. So don't go polishing out the surface with any creams or powders. A Citronox solution is a gentle and effective cleaning agent, and we recommend that it be tried first. If Citronox isn't effective, it may be necessary to use a more aggressive cleaning agent, such as nitric acid. However, we recommend that nitric acid not be used unless it is completely necessary. Nitric acid is more corrosive than Citronox, and prolonged use will reduce the lifetime of the cones. Even Citronox will attack copper cones, so the cones should not be exposed to high concentrations of Citronox or exposed for a long period of time. Also, when cleaning cones which have a screw thread, Be particularly careful that the thread is not contacted by nitric acid. And pre-soaking the cones in a detergent such as Fluka RBS 25 prior to cleaning with Citronox or nitric acid will help with the cleaning process. So why did I mention the ConeGuard? As mentioned previously, when cleaning cones which have a screw thread, it is important that the thread is not contacted by a corrosive solution. If the thread gets corroded, the cone may not seal correctly, or it may actually bond to the base and become difficult, sometimes impossible to remove. And with platinum cones, the thread is likely to wear out before the platinum insert. The ConeGuard thread protector seals the threads and protects it from corrosion during the cone cleaning process. Before reviewing the cleaning procedures, we just wanted to remind everyone that these procedures are available on the Glass Expansion website within our product care select section. In addition, let's review a few precautions. Always use proper PPE, including safety glasses and protective gloves. Be careful when handling the cone. The tip is very easily damaged. Only hold the cone by its edge and only use light pressure with your hand when cleaning the tip. Never use tools for cleaning cones and never ever insert anything into the cone orifice. Again, remember that the cleaning process does not necessarily need to reproduce the original like-new polished appearance. While sample deposits need to be removed, it is usually not a problem if the cone is discolored. Again, this may actually result in a more stable signal. There are three common methods of cleaning cones, from the simplest and gentlest to the most thorough and aggressive. Please note, before performing any of these cleaning methods, you should first simply wipe the cone with a cotton swab and DI water. The recommended concentrations of Citronox and nitric acid and wash times should be used as a guide only. Given the wide range of ICP-MS applications and sample types, you may need to experiment a little to find the best cleaning procedure for your particular application. Again, we recommend that you do not use nitric acid any more than is necessary, since it will attack the cone materials. If nitric acid is used excessively, the size of the cone orifice may be increased. If this happens, or if the tip is damaged or deformed, again, the cone will need to be replaced. Here's an example of cleaning method A. As mentioned previously, the first cleaning method you should try is routine cleaning with a cotton swab and DI water. If this was not suitable, the next most gentle method would be method A. This method just involves soaking the cone in Citronox. We won't read through these step by step, as they are available on the Glass Expansion website within our product care section, but we will at least highlight through the two slides. Cleaning method B is slightly more aggressive and should only be performed if method A was not sufficient and successful in cleaning the cones. It uses the same chemicals used in method A, but adds sonication. This is just a continuation of cleaning method B, steps 5 through 9. Cleaning method C is the most aggressive, and again should only be used if method B was not sufficient, as it involves the use of nitric acid. It is the same procedure as method B, but replaces the Citronox with nitric acid. Again, here are the steps 5 through 9 for cleaning method C. And just a final note on reinstallation. After cleaning your sampler and skimmer cones, it is extremely important to check the condition of the cone consumable parts. Many sampler and skimmer cones rely on a gasket or O-ring to make a proper seal. And installing either a new or recently cleaned cone with a worn gasket or O-ring can prevent a proper vacuum and result in the rapid overheating of the cone. Likewise, some cones require additional screws for installation within the interface. And heavily corroded screws can result in the same issues. In some cases, they even result in elevated iron backgrounds since they are made from steel. So we recommend that the sampler gasket be changed each time you change the sampler cone to ensure a proper seal, and to regularly check the conditions of O-rings and replace them if they show any signs of cracking. And that brings us to the end of our presentation on ICP-MS cones. Thank you all for your time today. We'd be very happy to take any of your questions. And if you're interested in a quote, you can contact one of our 3 offices directly at your leisure. We also have a global distribution network that can be found on the Glass Expansion website.